Welcome back, everyone. I know we are super excited to be in Unit 7, which is quadratic models and functions. And today we're going to be finding roots and vertex of a quadratic formula. So go ahead and write down the title, write down your academic language. Please go get a calculator if you did not grab one when you came in. We are going to be using some of the graphing part of that to find the roots and vertex. So pause, make sure you have this written down, and then come back and look, I'm already here because I didn't go anywhere. So I would like to introduce to you the two forms of a quadratic equation. So just a reminder, like before we had the y equals mx plus b, okay, and that's the y-intercept form of a linear equation, right? So it's nothing new, but we just have two, and I think there's actually three quadratic equation formulas, but we're just going to introduce two for right now. So the one that we've kind of been using already with transformations is y equals a times x minus h squared plus k. And this is called the standard form or vertex form. You may hear it either way. Standard form or vertex form. I don't know why that A didn't come out first. Standard form or vertex form. Okay, and we know that the H moves it horizontally. Oh, I just figured that horizontally in the H they match up. And the K on the end moves it vertically up and down. And the A right here makes it skinnier or fatter, right? And we know this, we've been working with this. That's the standard form or the vertex form. The other is called the general form, and we're going to be using this a lot, and you probably used this last year when we were talking about quadratic equation, and that is A times x squared plus B times x plus c, which is our constant, and that is our general form. Okay, and you know what? Let's go ahead and put the factored form, which, if you remember, was x plus, and then let's use two different letters here since we've used all of these and I don't know if there's a standard one. Okay, remember this factored form, x plus, actually let's just use a and b, and x plus b, and that's factored form, okay? So all different ways you can write a quadratic equation. Today we are just going to be concerning ourselves with the first two, and really just the first one since we're talking about the roots and the vertex. Alright, so I'm going to give you an equation in general form, and let's put it in our calculator. So you're going to put it in y equals, you're going to put it in the y equals and the y1. And the general form is going to be y equals x squared plus 3x minus 5. Okay, so I hope you may have already started doing this. Let's go to your calculator, go to the y equals, and we'll put x squared plus 3x, do this with me, make sure you're doing this with me, minus 5. And you guys know me. Oh, actually, I have something we're going to do later in the calculator. So I'm going to go ahead and go into my stat plot and turn that off really quickly. Okay. All right, you know me. I like to start off with Zoom 6 and see if anything comes up. Oh, look, a beautiful parabola in Zoom 6. So let's sketch that, transfer that sketch onto the page with your notes, okay? I'm going to pause while I do this, so it's going to pop up really quick, but that way the video doesn't last as long for you. Or, well, since you have to write it, let's do it together. So, and to sketch it, I'm just going to do, okay, I'm not going to put any numbers down yet, but it looks like, let's see here, it goes down here, and it hits here, and it hits over, it's farther here, right? And it's not very pretty, but there's the sketch of what this parabola looks like. Okay, so let's go ahead and fill in some numbers here, and while they're there, I'm going to label them because this is what we're finding. So these 2 points where it crosses the y-axis, these are the roots. Okay, where it crosses the x-axis, if I just said y, I can't even remember, x-axis, this is the y-axis. Okay, those are the roots. The bottom point, the minimum point here, and sometimes it's the maximum point, is going to be the vertex. Okay, and the line of symmetry is this line that goes straight up from the vertex. So if you, and remember my picture is kind of ugly, if you folded that over the line, if you could fold that piece of paper there where the line is, the 2 halves of my parabola should meet up. Okay, if I folded it there, they should lay it on top of one another. So let's go ahead and fill in some of those numbers. Where are my 2 roots? Well, that's where my x is, where my y is 0, right? So let's see if we can look at the table. Well, let's see if we can trace first. I'm going to trace. Where's my spider? Nope. Nope. Back to the graph. Trace. There's my spider. So where my y is 0, so I know I'm getting close right there. It's going to be close to x equals 1, and it's going to be close. Let's go to the other side. To x equals -4. So let's see if our table has exact answers. Okay, so when x is 1, y is -1. So it's not quite there, right? And when x is -4, y is also -1. So neither one of those is too close. So I'm going to go back to my graph. And then what I'm going to do is I'm going to trace over there pretty close. And I'm going to, what I told you guys last time, but we didn't do, I'm going to second calc. I want to find, ooh, look, I can find the 0 because it's on the axis. Hit enter. Left bound, yes. Right bound. Actually, I'm going to move it a little farther right. Enter, guess, yes. Okay, so it's -4.19 on this side. My x value here is -4.19. And my x value on the other side, I want you to try to do the same thing that I just did on your own. Trace over close. You have to be close to where it crosses the axis. Trace over this way, close. And second calc 0. Okay, left bound. This time I need to be under it since it's left bound to the left. Hit enter. Arrow over. Enter, enter. So it looks like 1.19. Okay, so this x is 1.19. And the y is 0 there, right? That's why it's called our roots. Or another word for roots is the zeros. A lot of times will be the zeros. That's where your y is 0. That's where our roots are. Let's see if we can find our vertex. I'm going to keep tracing on my calculator. Down, 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 down to the very bottom here. Can I find my vertex? It looks like x is going to be close to negative 1.5. Let's see if we can't. Let's practice this again. Second calc. This time I want to find the minimum value. I want to find that minimum number. It's the lowest part of the graph. I hit enter. If you're not keeping up, just pause. But I would really love for you guys to actually be entering this stuff into your calculator so that you know how to use it, okay? So left bound means to the left of where I want to be. So I'm going to hit enter, make sure I'm to the left of the minimum point. Then right bound, I want to make sure I'm to the right of the minimum point. I'm going to hit enter. Do I want to guess? Yes. And it looks like I'm going to round it to negative 1.5 and y is negative 7.25. So right here, at that point, its x is negative 1.5 and my y is negative 7.25. Okay, so with these pieces of information, I'm going to be able to change this equation from the general form to the vertex form. So what that means is I'm going to write down the vertex form down here, and we're going to see where we need to put all of these numbers, right? So y equals a times x minus h squared plus k. I'm going to turn my page, but you guys probably still have enough room to be writing on your page. But I'm going to go ahead and put my steps down. And what we're going to want to do is step 1. Okay, we want to find h and k from the graph. Okay, and what that means, remember, h, if you remember from translating our functions, I'm going to write this up here again really quick on the side. Y equals a times x. Oops. That didn't work very well. Y equals a times x minus h plus k. Remember, h is moving it horizontally, so I took a regular parabola, the parent function, and I moved it horizontally. Instead of being at 0, my graph was now at, look over here at the calculator. Instead of being at 0, I moved it horizontally here to, and it was negative 1.5, right? So in this case, h, I moved it to the left, so it was plus, right? If it was to the left, it was plus. Look at the poster and double check, but I'm pretty sure that's correct. So that was to the left, so that was a positive 1.5 move. And for my k, we moved it down, and the bottom instead of 0 was negative 7.25. So this h part is a little bit confusing because what this positive means is we moved it to the left, okay? But the actual h value is that k value at the minimum. So the actual h value is negative 1.5. But check this out. When we put it into the equation is minus, right? It's x minus, and then my h value, which is negative 1.5. Well, this minus a negative becomes plus 1.5, which means we move it to the left, okay? And then on the outside, we still have its plus, but it's negative 7.25. And I'm kind of old school. I really like to write this with only one sign in between numbers because two signs is sometimes too confusing. So I'm going to rewrite this as y equals a times just x plus 1.5 minus 7.25. Plus a minus is the same as just minus, and minus a negative is the same as just plus. So this means we move it horizontally left 1.5, right? And then down 7.25. Okay, so that's all stuff we remember. Oh, you guys, I didn't have my squared here this whole time. I hope you haven't already told me I missed that. So this is stuff we remember, but what the heck does that A stand for? What the heck does that A stand for? Well, remember that's making it fatter or making it skinnier. And I can tell already from this one that it's not changed, but sometimes it does. So I want to go through the process of what that would look like, okay, to find A. In order to find A, I can put something in for y and something in for x, and then isolate A and solve for A. So I need one other point on the graph, so I'm going to use one of the roots, okay? And in both of the roots, let's go ahead and use the root that was where x was 1.19 and y was 0. Remember, y is always going to be 0 at the root. And let's substitute those in. So instead of y, I have 0 equals, my a stays the same. Now I have 1.19 plus 1.5 squared minus 7.25. I'm going to add 7.25 to both sides. So I have 7.25 equals A times 1.19 plus 1.5. Let's see. 1.19 plus 1.5 is 2.69, right? Squared. So I'm just going to square that, which means times 2.69. So I get 7.2, and if I round that, it's 7.24. So 7.25 equals 7.24 times A. So if I divide both sides by 7.24, well, this is almost 1, right? And I'm pretty sure that it is 1 since I rounded those numbers from the graph. So I'm going to say my A is equal to 1. What does that mean for my equations? What that means, ladies and gentlemen, is y equals 1, but since 1 times anything is itself, I'm going to just ixnay that. So we're just going to have parenthesis, but remember there's a little invisible 1 here. We figured out A was 1, but it doesn't matter, so we leave it out. X plus 1.5 squared minus 7.25. Okay, so we took a graph on the calculator and we successfully turned it into a vertex form. I'm going to have a practice problem for you on the lesson plan. So remember, always go back to the lesson plan when you're done with something to read what's next for you to work with on your partner, and I will be around to help you out.